All right, we're going to continue working on system of equations, in particular with wind and water current problems. So let's start off with water. Suppose you can paddle a canoe at the rate or speed of 3 miles per hour in still water. Well, if you paddle downstream on a river that has a current traveling at 1 mile per hour, your speed then is increased. You've got your original 3 plus the current pulling you along. You now move at 4 miles per hour in that situation. But if you paddle upstream against the current, your speed then is reduced. You have original 3 and you're going against the 1 mile an hour that the current is traveling, and that moves you down to 2 miles per hour. Does the current affect the travel time? Well, the calculations we're about to do will show that the water current activity that's happening, it will indeed increase the time of the round trip, but it will decrease the average speed. And we're going to play that out and you'll see that. Well, here's some information. Suppose you travel 12 miles, so that's our distance, downstream, and then 12 miles back. So 24-mile trip going on here. The time for each trip can be found by using these following formulas here. Time equals distance divided by rate. That's what's happening there. And the distance is rate times time. And we're going to use this table to kind of help us see what's going on. So we have ourselves traveling down the current, and we have ourselves going up the current. We know that the distance is, and we're going to look at these two separately here, because you can kind of see the two happening between them. The distance is going to be, we're going 12 miles, and we are going 12 miles both ways. And right now we're just looking at no current, okay? The rate of traveling at no current down the stream is going to be, we go 3 miles per hour. And upstream is 3 miles an hour. And the time for this one, according to our formula that we're doing, is our distance divided by our rate. And we should be traveling at about 4 miles per hour. And our average rate going upstream, again, is our distance of 12 divided by our rate. And again, it's 4 miles per hour. So we can fill the bottom part in here. Our total distance is going to be the 12 going and our 12 returning. So that is 24 miles happening. Our total time that it's going here is 4 plus our 4. Yeah, this is hours. Those labels are incorrect. Let me see if I can do this. Those labels are incorrect. Those are actually going to be hours. And so that, which brings us down here to time, is 4 plus the 4 is going to give us our 8 hours. And our average speed is our total distance. So we want a total of 24 miles. And it took us 8 hours to do that. So that's miles and that's hour. And when you divide that out, you end up with 3 miles per hour, per 1 hour. Let's take a look what happens if there is a current. So the current we read on the last slide was that the current travels at 1 mile per hour current. Let's see how that plays out. Okay, so my rate is I'm normally traveling at 3, and this is going downstream with the current, so I get to add 1 to that one. So I am at 4 miles per hour. When I'm going upstream, I have my 3, but this time I'm taking away that 1 mile an hour current that's pushing against me, so I'm actually only going 2 miles per hour in that situation. My distance is the same. Okay, I'm still traveling the same river, but it just has a current involved in it. To figure out my time, I need to take my distance and divide it by my rate. So 12 divided by 2 is going to be 3. That's how much time it's taken me. I'm going to do the same thing for the second one. It's still the 12, but my rate changes. It's no longer 3, but it is 2. I divide that out, and I get 6. So my total distance has not changed. I'm still traveling 24 miles on the river. My time has changed. It's the 3 hours one way and 6 hours going upstream because I'm working kind of against the current, which is 9 hours. And that's going to be miles. And I can use those two pieces of information to get my average speed. And my average speed is going to use the 24 miles per the 9 hours. And I want to get that average speed, so I'm going to get my unit rate. So if it's 24 miles per 9 hours, if I divide those out, I'm finding that it's 2 2/3 miles per hour for the whole trip. Here's a situation that happens with wind. We'll come back to this one because we're gonna do another river problem first. So let's do this example here. Why don't you go ahead and press pause and try it out. Build this out a little bit and then see how you did. Maybe we can do this together. So we're going upriver, we're going downriver. We've got our rate, we've got our time. These are the different elements we need, and we have our distance, because our rate times our time equals our distance. So again, why don't you press pause, build this table out, work through, and then come on back and see how you did. All right, I'm going to keep going here. So for my rate, if I'm going up the river, that's like against the current, I'm going 5 miles per second in still water, but the current is 1 mile per second, so I need to subtract that out. So my rate right now is 4 miles per, looks like it's traveling per second. And then when I'm going down, I'm going to be using the current, so that brings me to 6 miles per second. The amount of time, I'm not sure yet, but I know my distance. Now I'm going to look here, it's 300 miles upstream and then return, okay? So 300 miles is not the whole trip, it's each leg of the trip. Something to pay attention to as you're working on this. So 300 one way, 300 the other way. The time we can find out by taking 300 divided by my rate, and I get 75. That's how long it's going to take me. And my distance, if I go 300 and I'm going at a rate of 6 miles per second, that should give me about 50. All right, so now I can answer my questions. A, the total distance. So my total distance is going to be my 300 one way, 300 the other way. It's be 600 miles. That's what I'm traveling. B, my total time that I'm playing out here is going to be 75. I'm going upstream, kind of against things, and 50 minutes going downstream, kind of with the current. I should be going faster, and that'll be 125. Looks like minutes for this one. Although I'm seeing seconds. Let's see. That meters per second. That's a second. Something seems fishy about that one, but I'm going to play it out. I'm going to keep going. So he says this one, we're looking for the average speed. So my average speed is going to take my total time traveled and my total time that it took me, and I'm going to divide those out to get the unit rate. It's about 4.8 meters per second. Now that sounds right. So 4.8 meters per second is what I'm traveling on this river for this entire trip. Now we're talking about wind speed. So let me come back to this slide right here. So if R represents the rate of the plane when there is no wind, just traveling along, W is going to be the rate of the wind. So that would tell me then that my rate plus the wind is when the plane is flying with the wind. And when I do R minus, I'm considering the plane flying against the wind. So there's my rate minus, and then there's my rate plus. So a couple things to keep track of. It's just like the water one. It's just now we're talking wind. Let's try it out. Okay, so I'm going to go with, well, there's no N in with. I'm going to go with the wind. I'm going to go against the wind. Okay, and then I've got my rate. I've got my time. And that's going to equal my distance. Now, I encourage you to press pause and see if you can build this table out. All right, my rate. So when I look at my rate that I'm traveling at, the jet can travel 6,800 kilometers distance between New York and Paris. Okay, so I know my distance. It's 680, okay. 6 hours and 48 minutes with the wind. So I know my time. So 6 hours and 48 minutes with the wind. I got to take the 48. I'm going to take 48 divided by 60, and I'm going to get 0.8. So that I can get my time to be 6.8. And then against the wind, it takes me 8 hours. So I have my time. My rate is going to be whatever my rate is plus the wind, and against the wind is going to be whatever my rate is minus the wind factor. So when I look at distance, I know because my formula is rate times time, I can take 6.8 times my rate, and that's going to be my distance. I could take my time of 8 and multiply it by my rate. So I've got my time minus my rate, and that should equal my distance. But when I look up here at the story, it's telling me that my distance is 6,800. I can use this now to solve it. So I'm going to take my first equation. Let's see. So let's take my first one. 6.8 times r plus w, and we're going to solve this system. I'm going to divide everything by 6.8, and I'm going to end up with r plus w equals 1,000. I'm going to work on the second one, which is 8 times r minus w. Let me divide by 8, and I get r minus w equals 85. Well, I have my two equations, and I'm going to stack them to use elimination to solve this system. So r plus w equals 1,000. R minus w equals 85. The w's cancel out, and I get 2r equals 1,000. I'm missing a number here. That should be there. Yeah, there we go. That looks right. Yep. 2w equals 850, right? Yeah. There it is. And it's blue now. Nice. That's right. Because my rate ends up being 925. There we go. Well, now that I know my rate, I can use that, because if I look at my original question, what I'm trying to find for is find the rate. Okay, so my rate is 925, look at my units, kilometers per minute. So it's 925 kilometers per minute. And then I want to try to find the rate of the wind. Okay, I can use any of my equations. I got a bunch of them here. I've got one here, I've got one here, one here, one here. I can use any of them. I'm going to pick this one right here as being the easiest. So 925 plus w equals 1,000 minus 925 from both sides. My wind is going to equal 75 kilometers per minute. All right, let's do another one of those. Let's try this out. Example 3, again, go ahead and press pause and you can try this out. Come back and see how you did. Considering that my rate is always going to be, especially with my plane here, without even reading the story, I know if it's with the wind, it's going to be my rate plus the wind's rate. And against the wind, it's going to be my rate minus the wind rate that's going against me. Let's see if there's any information I know. A plane can fly at 3,750 kilometers in 3 hours with the wind, so I know my time with the wind is going to be 3. The plane takes 5 hours to go against it, so that would make sense. It takes longer. All right, and my distance is going to be, now remember my distance is my rate times my time, so I'm going to fill that out. And I know that the distance the plane can fly, 3,750 with the wind. That's the same distance. Okay, what I'm looking for, as I'm seeing, is the 3,750 round trip, or is it one way? This is one way, so I know I can do 3,750. It's a detailed thing that you and I need to pay attention to. All right, I have my two equations. And I can now begin to solve this system. I'm going to divide both sides by 3, so I can end up with r plus w equals 1,250. I can look at my second equation in the system. That's r minus w. Divide both sides by 5, so I end up with r minus W equals 750. And that's a 50 there. 50. All right, I'm going to go ahead and align these two equations so I can use elimination. W equals 1250. R minus W equals 750. W's cancel out. I have 2R equals, if I add those together, I end up with 2000. Nice. Divide by 2. My rate is 1,000 miles per hour. Well, now that I have my rate, I can use that to find the rate of the wind. So this is my rate, plus the rate of the wind is a total of 1,200. So I can subtract 1,000 from both sides, and the rate of the wind is 250 kilometers per hour. Excellent. Well, keep practicing this stuff. It'll get easier as you do it more. All right, I'm going to go and paint a wall in my classroom with Q-tips.